Hello, I am Milad Ranjbar. Our group prepared this presentation about our research on fake news analysis in Persian-speaking communities for the NetSci 2020 satellite workshop. The epidemic use of virtual space communities arises the problem of fake news around the world. There are many studies about fake news detection and diffusion. One of the largest studies is the recent paper of Surush Vusuri about the spread of fake and true news in the English-speaking Twitter community. They classify 4.5 million tweets as true or fake using information from 6 fact-checking organizations. Then they made retweets trees and found out that the fake news diffusion parameters are different from true news. For example, falsehood diffuses deeper and faster. This research inspired us to study news diffusion in the Persian community. So why Persian? First of all, Persian is the official language of our country and is one of the Indo-European languages. Iranians usually call it Farsi. The Persian-speaking community is wide and includes more than 110 million people. Also, the number of pages including Persian contents on the internet has reached the 8th rank in 2019. So we chose Persian language for our study. The first step was finding labeled tweets because there is not any pre-prepared data set of Persian tweets with fake and true labels. We had to find an idea for detecting fake news ourselves. We defined fake news as news that is deviated from true news. We also call it false news. What do we do when we hear some news to check if it's trustworthy? People usually search for some reliable news agencies or fact-checking websites. Our idea is to train an NLP model to check each tweet with reliable sources to find out any deviation from truth. We provide a pipeline for this purpose. First, we prepared a dataset. We use Twitter APIs and some tools like Twint to crawl tweets with special keywords and dates from regular people and reliable news agencies. We extract some features of each tweet like its text, creation time, number of likes, number of retweets, user ID, and his or her list of friends. For this step, we just work on the text of each tweet. We use text representation tools like TF-IDF to transform each text into a vector. As you can see, each tweet is represented as the endpoint of a position vector in a high-dimensional spaces, which is imaged in 2 dimensions for better sensibility. The next step is to cluster tweets. As we convert text to vectors, we can mathematically calculate distances between each 2 tweets. Since we use TF-IDF for the first step, the distances illustrate how lexically different tweets are. We need to choose radius name R1 for clusters of each news. It means that if the distance between a tweet and the center of a cluster is less than R1, the tweet belongs to that cluster, and they both are about the same story. For the next step, we are going to use supervised machine learning methods to classify fake and true news. The result of the last step was a bunch of clustered tweets that are lexically similar, but the semantic investigation is also needed to classify tweets. We opt for 2 approaches for this purpose. First, we measure the sentiment of the words in each tweet. By sentiment, we mean assigning a number to the polarity of a word to illustrate whether it contains positive, negative, or neutral feelings. For example, If these three sample words, beautiful, ugly, and water, are given to a sentiment checker, the output will be +1, -1, and 0 respectively. By summing the polarity of each word in a tweet, we can measure the sentiment of that. The other approach is the similarity check. The similarity check is to use a tool like Word2Vec to investigate the words semantically in addition to lexically. It means to train a model to understand the relation between the meaning of the words. For example, a well-trained Word2Vec model will recognize that beautiful and gorgeous are synonyms, while, while ugly and beautiful are antonyms. So, with this tool, we can find out how much tweets of a cluster are lexically and semantically similar to the tweets of the reliable news agency in that cluster. The result of these two investigations are used to train a classification algorithm named the decision tree. The result of our model is shown in the chart. In every learning algorithm, we can use some metrics to show the strength of our model. The two well-known metrics are precision and recall. Precision is the fraction of relevant instances among the retrieved instances, while recall is the fraction of the total amount of relevant instances that were actually retrieved. In other words, precision says if the model predicts a group as A, what is its accuracy of true prediction of A label in this group? And recall says if the model predicts a group as A, how many of them are truly labeled among the all real A data that we have? Our precision and recall for the true news class is 0.621 and 0.571 respectively. And these metrics for the fake news class are 0.467 and 0.56. One of the weaknesses of our model is the shortage of label data for training and testing our model. The other one is that the training dataset for our similarity check is not large enough. Furthermore, adding some more parameters for the supervised algorithm could amend the model. Although we did not get a good score for our model for fake news detection, we investigated the network of the collected data that we had labeled. The dataset includes 20 true and 20 fake news and their retweets. Then we made the tree for each of them. You can see two examples of retweets trees. These trees show how news propagates from a person as a root of the tree who tweets and other who retweets the tweet. Each node in the tree shows a user and the color shows the average number of tweets he posts per day, which we call activity. Blue is the least activity and red is the most. We investigate some dynamic and static parameters of the trees to find some differences between fake and true trees. Three features are investigated. Depth is the number of retweets hopes from the origin tweets over time, where a hope is a retweet by a new unique user. Size is the number of users involved in the tree over time. Structural virality is a measure that interpolates between content spread through a single large broadcast and that which spread through multiple generations, with any one individual directly responsible for only a fraction of the total spread. In these two graphs, each tree is pictured. Based on these two, it could be concluded that fake news diffuses deeper in a shorter time interval. In the depth versus time plot, we see that the average depth velocity in fake news is faster than true news, Also, the size versus time plot shows that the size of fake news trees increases faster than the size for true ones. Both mean that fake news propagates faster than true news. Depth. By comparing fake and true news in the histogram of depth, we can see that all of the true news have depths lower than 7, but only 80% of fake news have depths lower than 7. And half of the fake news have depths less than 2, but half of the true news have depths less than 5. This shows that fake news are more likely to be retweeted from users other than to its creator, but people usually take the true news from the source. About size. By looking at true news histograms, we can see that all of them have sizes less than 20 notes, but only 40% of fake news have sizes less than 20. This shows that people like to retweet fake news more. About the structural virality. The structural virality histogram shows that some of the true news spreads more than that fake news can ever spread. It may be caused by the fact that people will usually find out whether a news is fake or true after some time has passed from its creation time. Although our dataset is very small, the results are in conformation with Vossoughi's paper. So thank you for your attention.